So here we go, starting test review for Unit 12. Oh, I'm sure y'all are so excited. Okay, so a couple of things here. Let's make sure you've got this. Don't forget, perimeter again is at all sides, and the area of a parallelogram is base times height. But what happens if their height is missing? And you need to find the height, like say, and all you've got is say some angle measures. Well, then this is where this formula would help. Like if it says 60 degrees or 30 degrees, you would take the diagonal divided by 2 times square root of 3, and that would give you the height. Or if it's a 45 degree, then it would just be the diagonal divided by the square root of 2 to get the height. So, for example, okay, so if you look on your paper, you've got something like this that says 22, 10, and 45 degrees. Okay, so this 10 is the diagonal. Now, again, to find the perimeter, all you got to do is add up all the sides. So if you add up 22 plus 22 plus 10 plus 10, you end up with 44, 54, 64. Okay, so this would be 64 yards. But I need to find this height right here, and so to do that, here's my diagonal. So if I say, since this one's a 45, and I'm going back to this little bit right here, I'm using the 45 one, then what I would do is take the 10 and divide it by the square root of 2. When you divide 10 by the square root of 2, you would get your answer, or you would get your height. And so 10 divided by the square root of 2, I get roughly 7.07, so we'll say 7.1. And then that times the base, so I could say the area is equal to base times height, so the 22, which is the base, times the 7.1. And I would get an answer of 156.2 yards squared, or square yards. Okay? And that's it. So fairly simple. It shouldn't be that hard. Y'all can make sure y'all do that. Again, make sure you have what you needed to add to your notes for your formula sheet, or your cheat sheet as some of y'all prefer. Alright, let's look at number 2. Number 2 talks about right triangles. And again, right triangles, when we talk about the legs are these two ones right here. Doesn't matter where you put them. So like if I put here 16 and 24, that's fine. The point is, you would need the hypotenuse to get that. So what do I need? Again, keep in mind that area of a triangle is equal to 1/2 base times height. And if I have a right triangle, I can always do the a squared plus b squared equals c squared bit to help me find any missing side. So when I look at that, I can say here, like this is, I could say 16 squared plus 24 squared. By the way, you could just take the square root of all that, and that will give you this missing side. So when you do that, you get 28.8. So that becomes that. So the perimeter would be add up all the sides, which would give you 68.8 feet. And then the area is just 1/2 the base, which we'll say is 24, and the height, which is 16. Vice versa, it won't kill you. And you get 192 square feet. Okay, easy peasy, right? Alright, so now here's something else to add for your formula sheet, that the area of a kite rhombus is 1/2 the diagonal 1 times the second diagonal. The area of a trapezoid is 1/2 the height times the sum of the bases. And again, how would I use this? Let's keep in mind how we need to be careful about this. So I will try to make sure that you get, say, something where you can easily find those type of answers. So let's look at number 3 first, and then I'll look at number 6. That's the ones dealing with kites and rhombi. So on number 3, you've got something like this that's doing that. But notice that you've got this little marker that tells you that that's going all the way across. So use that idea to say that's D1, D2. Doesn't matter which one you say is D1, D2. Okay, and then you could just say that the area is equal to 1/2 of the 6 times the 19. And you get that area would be equal to 57 meters squared. Okay, how is that different? Like, how can I make that different? Well, look at the one for the rhombi. Okay, so like here you have an example And notice that there's congruency marks. You can see that on your review. And these congruency marks say that, like, okay, if this is 6, then this is 6. If that's 9, this is 9. So really here, D1 is 12. Like, you got to double that. And D2 is 18. And so then you would have the area is equal to 1/2 12 times 18. And that would get you an answer of 108 feet squared. Or square feet. I don't know why I keep saying feet squared. But anyways, so there you go. And that one's very simple. But notice, it's not very hard to see. These are little things that shouldn't trick y'all. You just got to pay attention. Okay, for trapezoids, that one should be fairly easy. You got a B1, which is 14.5. A B2, which is 22. And then a height, which is 12 inches. So then all you got to do to plug that in is say 1/2 of 12 times the sum of 14.5 plus 22. So just make sure you know which numbers go where, plug them in, type that into the calculator, and you should get 219 inches or square inches, and there you go. So fairly simple type of problem. Okay, and I'll show you what happens when we go in the reverse of that. So the next ones you need to know are the area of the circle, which is pi r squared, which is simple, and that if you, for some reason, I give you the diameter, you need to find the radius, is the diameter divided by 2. So, like on the example that you have with number 5, you've got this circle that is, say, 20 inches in diameter. So that means if I want the radius, I want to divide that by 2. So divide 20 by 2 and you get 10. And then you could say area is equal to pi times 10 squared. And that would give you an answer of 314.2 square inches. Fairly simple. Just got to remember that if you get the diameter, you need to divide it by 2 to get the radius. And then that's what you would plug into the formula. Okay, so on number 7, we want to do, that's asking for the sector of a circle. Again, that's degree over 360 times pi r squared. Keep in mind you can have 2 types. You could have one that goes like this, and the shaded area is in here, and then that's just a degree over 360. But if I give you the shaded area on the outside, and I give you an angle measure here, then you need to make sure you subtract that from 360 to get that degree that would go over 360. So on number 7, though, the way it's set up, you can say 128 over 360 times pi times the radius squared, which is 8. Press enter, and you would get an answer of about 71.5 centimeters squared. Okay? And that's about it. That's all you really got to do. You just got to make sure, you know, is it the shaded area in here inside, or if it's on the outside. And again, if it's on the outside, you're going to say like 360 minus the green before you place that answer over this 360. Okay, so what happens if I give you a trapezoid, or one where I give you an area and you have to find something else, like some missing side? So in the case of number 8, I give you a trapezoid that has a base length of 8 and 20 and an area of 140 square feet. And you need to go back and find the height. Well, okay, again, area is equal to 1/2 the height times the sum of the bases. So I can go here and say 140 is equal to 1/2 the height times the sum of the bases, which is 8 and 20. And then as it says right here, I can add the bases. So I've got 140 is equal to 1/2. 20 plus 8 is 28 times the height. And then multiply the half, or half of 28, which would give me 14. And then I can divide to get the height is equal to 10. In this case, feet. And that's your answer. That's it. So fairly simple. Here is something I'm going to ask you to find the height, and so you can do this and just follow those steps and you would have your answer. Okay, so again, what happens if I give you the area of a circle and you need to find the radius? Keep in mind it's very simple. If you backtrack everything, the area, if you take the area, divide it by pi, and then take the square root, that will give you the radius. So you could easily figure that out. So like on this one, on number 9, I could say 201.1 divided by pi, and then take the square root of that. And when you do, on the calculator, you'll get like 8.000000 something. So we'll just say that it's 8. So the radius here is 8. Okay. Like I said, that one can be done in one simple step. This does not change. You know, maybe I could ask for the diameter and say multiply by 2, but not that hard. Okay. So again, make sure you know what to do on, like, say, problems like number 10. Number 10 is similar to number 2. I had here 16, 16. I don't care about the 13 that's off to the side. 16, 16. And you could say, again, that a squared plus b squared equals c squared. And when you do that, you would get 22.6. Okay, and then add those up. That would give you the perimeter, 54.6 inches. And then base times height divided by 2. You get 128 square inches. And there you go. So again, that's stuff that's already been covered. Okay, so here you go again. The area formula for regular polygons is 1/2 the apothem times the height. I will give you the apothem and the height. So like on number 11, you've got, say, a hexagon. That's supposed to be regular. Go with that. That's 6.9 with an apothem of 6 feet. So all I got to do here for the area, first off, I need to find the perimeter. So let's talk about the perimeter. Perimeter is the number of sides. So in this case, 6. 6 times 6.9. And you would get an answer of 41.4. Then I would say the area is equal to 1/2 the 6, which is the apothem, times the 41.4. And that would give me my answer, which in this case is 124.2. Let's see, square feet. Okay, and that's all you got to do on that one. Number 12 would do the same thing. Okay, so on this one, the perimeter is going to be 6 times 8, which is 48. And then that means then the area would be 1/2 of the 6.9, which is the apothem. Again, there's your apothem, times the 48. And that would give you your answer, which would be 165.6. Again, centimeters squared. So that's all you got to do for those, and again, fairly simple. For composite figures, basically you need to make sure you can identify the different shapes that you're looking at, and then kind of come up with formulas that you would need to find those areas, and then you could add or subtract. So let's look at 13. Now, if you look at 13, so looking at 13, you basically have a semicircle. That's this part right here. Okay, so you have a semicircle, and you have a triangle. That's this end right here. Don't start thinking of ice cream cones or something like that. Okay, so how do you get the area of a semicircle? The area of a semicircle is, again, pi r squared, but again, divided by 2, because you're cutting a circle in half. An area of a triangle is 1/2 base times height, and make sure you have the base and the height. Now, notice here, this 3 goes all the way across, and the 7 goes all the way like this. So on this one, the area is equal to 1/2 3 times 7, which should get you about 10.5. Okay, here, this again is the diameter. So you would have to divide the 3 by 2 to get the radius is equal to 1.5, and then you could say pi times 1.5 squared divided by 2. And when you do that, you get 3.5. Okay, so then you add those two together, because this is together. They're being added together. So the total area, I'll put it over here, total area is equal to 3.5 plus 10.5, and that would give you an area of equal to 14. I'll put here 14.0 just in case. Square feet. Okay, and that's that. But look at 14. Number 14, you get a drawing where you have something like this, and you need to identify, and they're telling you here's an 8, and here's, I guess I should have something like this, 8, and so you got to recognize you have a rectangle, and again you have a semicircle. But this time the semicircle takes out, like here, the completed rectangle would be like this right here, and we're taking this part out. So that means I'm going to end up subtracting those two areas. So on this one, or you could say this is a square, by the way, rectangle, square, same thing. You've got 8 times 8, so that's 64 inches, square inches. And then a semicircle, this ends up being the diameter, so I could say here the radius is pi times 4 squared, because the radius would be, divide this by 2 and you get 4, divided by 2. And when you do that, you get an area is equal to 25.1. So then I would have to find my total area. I would say 64, because that's this area, minus the 25.1. And that would give me an area of about, let's see, 64 minus 25.1, 38.9 square inches. Okay? And that would be your answer. So you just got to recognize what are the shapes, add, subtract, that type of thing. Okay, last thing to add to your formula sheet, talking about similar figures. Again, new over old, and if it's the sides, okay, when you do new over old, you get a scale factor, a fraction, or some answer. That scale factor, if they give you the sides, you need to square that and multiply the old area to get the new area. If it's the areas that they give you, then you need to take the square root of that scale factor and then multiply it to the side to get the new side. For example, so you see here, like on number 15, okay, you can see, and how do I know what's new and what's old? Old to me is the one that has all the information, new is the one that I'm trying to get information for. So here on 15, the 11, on the smaller one, the one on the left, usually old is on the left, the one on the left, I need to say, okay, I've got the side and I've got the area. So that's my old. And then the other one's going to be the new. So here I want to say 44 over 11 is equal to 4. That's my scale factor. Since those are the sides, I need to square that, and that would give me 16. That would be the scale factor for the areas. I can multiply that to 20, and I would get the area for the new, or the one on the right, which would be 320. On number 16, they give you the areas, and so I could say, okay, again, notice that the one on the left has all the information, and I'm looking for a side on the one on the right. So I'm going to say 510, which is the new, versus 4,590, which will be the old, and take the square root of that. So if you type that in the calculator, you would get 1/9. Take the square root of that, you would get 1/3, and you can multiply that to the 21 to get 7. Notice how I set this up where you could do all of it all together at once, and then just press enter. So, pretty simple, right? Again, that's it for that. Make sure you have the formula sheet. It will be worth points. You will have to turn it on the test. If y'all have any questions, feel free to try to shoot them to me through Google Classroom, and I will do my best to answer them. But otherwise, guys, I hope y'all are ready. Good luck. Thank you so much for your time. Y'all take care.